So we'll take up cube and parallelepiped diagonals. On this video, we will be making a formulas for the diagonals, both cube and parallelepiped. First, we have to do first on the cube. So derive the formula diagonal D equals to square root of 3a for a cube. Find also the volume formula if diagonal is given. So this one is a cube. D represent diagonal and the side is here is A, usually denoted by A. So when we solve diagonal for this cube, we form a right triangle on this one, right triangle. So if we try to have this right triangle, we solve this one is your D, diagonal, and this one is your A, since that one is a cube. So this one is A, so this point here. So D, this one is A. So this one would be 90 degrees. So this one, let that one to be X, this one X. By Pythagorean theorem, you have that one, X squared is equals to A square plus A square. So your X would be simply square root of 2A square. So solving diagonals. So how to solve diagonal is simply Pythagorean theorem. You have that one, D square equals to X square plus A square. But your X square is this one, equals to A square plus A square, and you have that one plus A square. Or simply you have that one 3A square. So you have D equals the square root of 3A square, or the diagonal D equals to square root of 3 times A. So this one is similar to this formula, D equal to square root of 3A. This is the formula in solving diagonal of a cube. D square root of 3 times your side A. So for the diagonal of the parallelepiped, so to find a formula for the diagonal of a parallelepiped, so it follows similar procedure on the cube. So this one is your D, this one is your, make that one X there. So this one is C, side C, and B. So make that one as, this one is X. So make that one as an X. This one is A. You have that one is diagonal D. See the figure there. If we have to make a formula for diagonal D, it would follow on Pythagorean theorem. So from this figure, Pythagorean, you have that one X squared equals to B squared plus C squared. But diagonal D here, you have that one D diagonal D equals to x square plus a square, or that one is d square. Your d square, you substitute the value of x square, so b square plus c square. So d equals to the x square plus a square. So your x square is b squared plus c squared. So plus a square, or simply your diagonal d equal to the square root of a square plus b square plus c square. This is the formula to be used in finding the diagonal of the so-called parallelepiped. So you have two formulas there in finding diagonals. For the cube, you have the first one. This one is for the parallelepiped. So we'll take up an example. So determine the diagonal of the parallelepiped with c equal to 2, this one, b equals to 8, and a equals to 9. So this one is a. So you have this one, diagonal equals to the square root of a square plus b square plus c square, or simply equivalent to your a is 9 square plus 8 square plus your c is 2 square, or your diagonal would be equivalent to 149 square root of 149, or equivalent to 149 is 12.2. For this one, determine diagonal and volume of a cube whose side is 4 meters. So diagonal equivalent to, for the cube, as derived, square root of 3 times a, equivalent to square root of 3. Your a there is 4. Your a equals to 4. Then you have that one equivalent to 6.92 meters. So for the volume equals to a cube. Simply 4 cube. Simply you have that one 64 meters squared. So these are the uses of the two formulas in finding diagonals for the cube and parallelepiped. And how we do that formula, how to derive that formulas, you have the derivations, and once the problem concern on diagonal, you can use the formula directly.